Hey guys, so here's our video for week number 3 for my class. So I'm Miss Gray, obviously. Um, this is the slope-intercept form, basically topics that we're going to cover this week. And so I'll go through each one, but basically you need to start with an understanding of of what slope-intercept form is. So this is what slope-intercept form looks like. I also wanted to point out that there's other types of forms. So this isn't the only one. So it's like I've told students before, it's kind of like a person that goes by a few different nicknames in different situations. So, you know, maybe if your name was Robert, you might go by Robert at work, but maybe your friends would call you Rob, and maybe your mom would call you Robbie. So like there's different ways to like put the same thing in different forms. And so that's kind of how it works with linear functions. It's exactly how it works with linear functions. Some of the forms you can use are slope-intercept, which is what we start with. And then we'll also talk a little bit about standard and things like point-slope form, and you'll hear about those. But for slope-intercept form, this specifically is good for graphing. So this one helps with making graphs. And so if you think back to when you started graphing, you probably started by making an XY table, where you would pick numbers, for X, and then fill them into some kind of equation here. And then, decide what the answer was. So you get your outputs, and then you go through and graph each point and end up with a graph, right? You go through and put in 0, 2, 1, 3. So slope-intercept form is just a quicker way of doing it than this. So this is kind of the old way. All right, so if I'm looking at slope-intercept form, one thing to notice is y is by itself. So in order for something to be in slope-intercept form, basically the y has to be solved for, meaning that y is on one side of the equal sign, and then everything else is pushed over to the other side. We'll talk later about how to put it in this form, but for now, it's going to be just given to you this way. When you're looking at it, the nice part about it is that you can see the slope, which is the rate of change in the situation that you're dealing with, and then the y-intercept, which is that number that's off by itself. The y-intercept is on the starting place on the y-axis. That's kind of where it crosses the y-axis, and it's always the point 0 and then whatever the number b is, right? Because you're going 0 and then up or down to whatever point it is. In algebraic terms, this is a coefficient, right? Because it's in front of a variable, and then this would be like a constant because it's off by itself. All right, so that's kind of like a rundown of how slope-intercept form works. So then if I go in to the graphing situation, so topic UWB. So I'm still dealing with that idea of slope-intercept form. And if you'll notice, if you look here, so y equals blah, 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 it's set up in this format. And so the idea is that you can see how to graph it by looking at the number that's by itself, because this number tells you where to start. And it tells you where to start on the y-axis. So don't forget that, because I will say of all the mistakes students make, a lot of kids will put it on the x-axis instead accidentally. And then this tells you where to go. So that's based on the idea that slope is rise over run, right? Which would tell you how much to go up and down versus how much to go side to side. And we've talked about that as the change in y over the change in x. But it basically creates a staircase to find the next point. So if I'm looking at -5 here, this is the starting amount. So B says I start there on the y-axis. So I'm going to go down to -5 and mark it. And then this tells me where to go next. So 1/7. So this is one of those times where we like this to be a fraction. Because if it's a fraction, then we can see the rise and run easily. If it's not a fraction, we want to make it a fraction. But this case it is. So 1/7 means that from the point I marked, I'm going to go up 1/7. So for this example, 1 over 7 means I'm going up 1 over 7. I also like to point out to students that you could do the opposite of both of those things and end up going down 1, backwards 7, and also hit a point. So the other idea is that if you reverse both of those things, you end up with a point on the opposite side of the line. And you always have that option too, because sometimes it just doesn't fit over here, depending on how big the graph is. I haven't noticed that on IXL, but in teaching it, I've definitely noticed it on worksheets. Okay, so starting here at -1, right? So I'm going to come to my y-axis, mark -1. 1 over 8 means I'm going to go up 1 over 8. So hopefully you can tell it's a lot faster than using a table. This one starts at a +8, but this time I have a negative. So if I'm talking about a -1/3, that's really the same as saying -1 over 3 or 1 over -3, because this negative sign can either just travel out front or it would be up at the top or down at the bottom, but basically it has to have one negative sign. It's not okay to say -1 over -3. That's not the same. But as long as it has one negative sign, it doesn't really matter which side of the fraction you put it on. So in this situation, I always tend to tell students just to move it up to the top. So this would be looking at it like it's going, oh, I'm sorry, geez, going down 1 and then over 3. So that way students basically remember that you're either going up or down each. So if it's positive, go up. If it's negative, go down. And then whatever this bottom number is, just always go forward. I think students remember things better if it's just a consistent rule rather than something that changes based on other things. So if I start at 8 and it's negative, I'm going to go down 1 over 3, which would be the same as going up 1, backwards 3. All right, next. What if it's not a fraction? Then make it a fraction. And like I said, I would just take the negative sign up to the top. So this means go down 8 over 1. So I'm going to start at +8. I'm going to go down 8 and then over 1. All right, this one I'm going to start at +6. And it's negative, so I go down 1 over 4. So hopefully you get the idea. I think we've basically covered most of the scenarios here. So if it's not a fraction, make it a fraction. The only thing we didn't talk about is what if it looked like that, where you couldn't see the number, there was no number in front of x. So remember, there's always an invisible 1 here. So really this is 1 over 1. So these are the situations where you go up 1 over 1. So it didn't show us that, just in case. Okay, let's move on to horizontal and vertical lines. So horizontal lines and vertical lines are straight, they're straight, linear kinds of things. This situation is where the slope is 0. So remember, these were the graphs where it would be like a ram that was flat. So it doesn't have any tilt, has 0 tilt. So the slope is 0. So when I'm filling it into y equals mx plus b, really I'm saying y equals 0x plus b, right? And since it's 0x, it's really just saying y equals b. So this is a situation where you end up saying y equals some number. And whatever that number is really the y-intercept, right? Isn't that number here the y-intercept? So really here, whatever that number is where it crosses here. So if I was going to give you a couple of examples, y equals 1, y equals -3. So if I was going to graph these are going to be horizontal lines that go through this number on the y-axis because these are the y-intercepts. So this one has a y-intercept at 1. So let's say that's 1. It's going to be a horizontal line through it. Or this one would be, let's say down here at -3, a horizontal line. So pretty straightforward. This situation is different. This kind of line doesn't have a slope. This one has an undefined slope, which we talked about that word impossible. Because it has an undefined slope, It's not a function, so it's the only straight line that doesn't pass the vertical line test, because if you draw a vertical line over it, then it crosses multiple times. So the way we came here and just plugged a number in for m, we can't do that here. This doesn't even follow the same pattern at all, but it is the opposite of what happens here. So the idea that this is y equals a number, since this is the opposite kind of line, this is going to be a situation where x equals a number. But hopefully, if you're thinking back to the first page I put up where I said in slope-intercept form, you have to have y by itself, this is also why it's impossible, because this doesn't fit. There is no y. So it's not in slope-intercept form because it's not y equals. So it just doesn't work in any way other than the idea that you can graph it and do that kind of thing to work with. So if I'm looking at this situation, I'm basically looking at lines where I'm going to have some point marked on the x-axis this time. So it's the only time I don't start on y, I start on x, and it's going to be, you know, a vertical line that goes through that point. So if I was going to do similar kinds of examples, x equals 1, x equals -3. This time I'm marking 1 on the x-axis and then marking -3. So that was how I remembered it when I was in school. You just kind of have to find a way to put that information into your memory, and practicing it a lot will help that. But I always remembered it like if it was y equals, then I put that number on the y-axis and I make it horizontal. And if it's x equals, then I put it on the x-axis and make it vertical. So this will help practice. IXL is good for this kind of practicing again and again. So y equals is horizontal. This is horizontal, right? And it says to write the equation. So a horizontal line is y equals, and it crosses Fi. So it's not very difficult. You just have to memorize it. X equals is vertical. And another y equals, this time -6. So I feel like you can handle that. And then the next topic, BTK. Ooh, BTK. This topic is the same, but just going the opposite direction. So this time it gives you the equation. You have to make the graph. So x equals is vertical. So I'm going to go to -2, and then just I can put my other point anywhere on this line, so just anywhere. X equals, again, vertical. Equals is vertical. So not very hard, just lots of practice so that you memorize it, which is probably honestly maybe the best way I've ever taught it, just because you'll end up doing a lot of problems and it'll stop you once you've memorized it, basically. Okay, so then we move on to graphing. Oh, you know what? I put this in the wrong order, I think. Of course it did. So this one, to write an equation from a graph. So if you're looking at a graph and you want to make an equation, so you're turning a graph into an equation, basically you just need two things, right? Those same two things that we keep talking about over and over and over again. The starting amount and the next place you go. So if I'm looking for the starting place or amount on the y-axis, and then the other thing I want to know is where it goes next. So I need to know the rate of change of the slope, which I can see by just finding points on the graph. And I'm going to plug these things in, right? So this is what I would be calling B, my starting amount, my y-intercept, and then my slope is m. So still y equals mx plus b. So let's do some examples up here. So this one starts at 2. So if I'm thinking of taking something like y equals mx plus b, and then filling in numbers, this one starts at 2. And then it looks like if I'm looking at the points, b equals 2, m equals, so from 2, I'm going down 1 over 1, 2, 3, 4. So negative 1/4. So it's a little awkward the way they have you type this in. I wish they made it look like a fraction, but you can just put it in like that. Okay, next example. This one starts at -4. And then for slope from -4, it goes down 1 over 1, 2, 3, 4. Ooh, same rate of change. But this time, since it's a -4, remember that that really counts as like a -4 there. And then -1 divided by. All right, another negative slope. So this one, b equals -3. And slope is another -1. Oh, this one over 5. So this time I'm going down 1, but over 1, 2, 3, 4, 5. So hopefully you're getting the idea that it's basically the same things over and over. You're just having to figure out what the actual numbers involved are. Oops. Don't forget your x like I just did. Okay. Look, this one has a pretty big slope, right? It's going to be a larger number. So it crosses here at 5 on the y-axis. And then my slope, it goes down. If I'm going all the way down to there. No, here's another one right here. So if I'm here, I have to go down all the way from 5 here, right? So 1, 2, 3, 4, 5, 6, and then over 1, which you can just put as a 6. If you put 6 over 1, though, it won't make it wrong. Plus. Oh man, how did I get that negative sign in there? Well, maybe I hit it accidentally, or maybe I did it dumbly while I was talking. But either way, that negative sign shouldn't. Wait, what did I enter? Oh, I didn't enter the negative sign. See? Do you see what happened there? It was down 6 over 1. So good example. Here, the most important thing, most common mistake is pay attention to sign and direction for slope. So that is one thing that I will say, and I literally just made that mistake in front of you, which is hilarious. If you're looking at a slope that goes down, then you should be writing an equation that has a negative sign in front of it, right? So if I wasn't moving so fast, I should have double checked. If I was you, my advice would be to double check and make sure that that you're looking and seeing, does it actually say negative? Which is a lot of times the mistake I see on tests and quizzes and things, is students will put everything right. They just won't remember to put the negative sign. And they'll do it inconsistently enough that I can tell they're doing it sometimes, but they're forgetting to do it other times. So just be, just be careful, because it's easy to make that mistake. Okay, I think you have enough information to work on that, and then you can always ask me more questions about it. Word problem part, this is where I am still thinking about that starting amount and changing amount, but now it's written out in words. So the starting amount is still that idea of B, and the changing amount is still the idea of M in the same equation. So if I'm looking like this example, Christine earns $8 for each hour of yard work. This is always going to be a rate. So it's going to have words like per or each or every, where it's saying it's this much per day or this much each day or this much every day. So it's like an amount per, so it changes. So if Christine works 1 hour, she only makes $8. But if she works 10 hours, she's going to make $80. So this is a changing amount. So in this example, it doesn't give me a starting amount. If I go through and read this, there is no other number besides that 8. So in this example, B is 0. There is no starting amount. She just has to start earning money, and she is earning money at $8 an hour. So this would be y equals 8x. And you could put plus 0 here, but you don't have to put that plus 0 at the end. You could just put 8x. So y equals 8. So for this one, same idea. Jeffrey earns $2 for every cup. So again, that word every. So we don't have a starting amount this time, just like last time, but this time the changing amount is $2 per. So it would be y equals 2x. Basically just meaning 1 cup is going to cost $2, right? 2 cups is going to cost $4. So as you plug in amounts for the amount of cups, then you're getting how much they make. Okay, let's jump forward to something more challenging. All right, so here we go with a few extra things added in. So Aubrey owns 2 novels already. So that's the starting amount, right? She starts out with 2, and she can buy additional ones at the rate of 1 per dollar. Again, so there's that word per. So that's our rate. So it's 1 per dollar. So I can write that as y equals 1x plus 2, but I don't have to write the 1. I can also just write x plus 2. All right, Daniel already owns 3 stamps, and he gets an additional 1 stamp per dollar. Oh, sorry, additional price out. Yeah, 1 per dollar. So 1, which again, just like last time, I'm going to put x plus 3. So I don't need to include the 1 in front. All right, so when ringing up a customer, a cashier needs 5 seconds to process payment as well as 1 second to scan each item. So when this cashier gets a customer, he knows for sure, or she knows for sure, that it's going to take the 5 seconds to process it, the payment, plus it's 1 second to scan every item that gets purchased. So that's the changing amount. That's the per, right? And it's 1. It keeps giving us 1. Y equals 1x. So I'm going to skip forward again and see if we can find something that are a little harder. Let's do the very last one. Okay, so for this example, when ringing up a customer, a cashier needs 15 seconds to process payment. Oh, so they're not even getting creative with this. They're just kind of like putting them together. So 15 seconds, and then it's 5 seconds per. So really, you're just plugging those numbers in, 5x plus 15. So I feel like you have enough information to do that then. All right, awesome. Hopefully that helps.